All right, you tell me where you want to begin.
Just number 1.
Let me open my writing tool here. Hold on. Hold on, sorry. Yeah, I'm just going to try doing this like this. Okay, so what does collinear mean?
Like on the same
On the same line.
Line, yeah.
If you look at the word right there, line in it.
Mm-hmm.
So what points are collinear with K?
J and L.
And H and M?
Yeah.
And N?
Yeah.
Actually, I'm not sure about N, as in Nancy, because that is an extension of a line, MK. In other words, that's not actually a line from K to N because it's dotted. I think. I'm not quite sure what they're trying to say there. And I'm not sure if it's collinear or not. So, in other words, does it have to be the extension of a line or does it have to be on a line segment for it to be collinear? And I'm not sure. For sure, J, H, L, and M, as in Mary, are collinear with K. N is the suspect. And B is not, because B is not a point. B is the name of that line. Line H, K is B. Okay, give another name for line B.
HK.
I think maybe this.
Oh yeah, you need that above it, yeah.
Really think. I'm not sure exactly what they're looking for there. What other name could we give it? We could give it HK. They've already given it line B. The thing is that, okay, here's the way it works. Line HK is another name for line B. Line segment HK is merely from there to there. And it is not another line for B, or another name for B. It's a name for that segment. A segment having closed point on both ends. A line being open-ended in both directions. Name the intersection of line C and plane R. Well, there's plane R.
K, right?
Yeah, there's line C, and it intersects that plane R at K. So that would be K. Name a point non-coplanar to plane R.
Would it be like N?
Okay, what else? That for sure. It's not on the same plane.
N and M, right?
M and N, and that's it.
Yeah.
All the other points are on the same plane. All right, let me scroll down here. That's the one advantage of doing this. However, let me change the color. Let me make it a better color. Let me scroll over a little bit. So we can see the whole thing. How many planes are shown in that figure?
Wouldn't it be like 5?
That's what I think. In other words, that inner rectangle or parallelogram is the same plane as
As
the
W.
outer plane.
Yeah.
So that's not two different planes, that's one plane. And then you have
Right.
the planes that are that edge, that back one, and that one. Well, 1, 2, 3, 4. There's 4 sides to that. How do we know that? Because when you look at it and you try to separate them, I made a mistake and saw only 3 for a bit. So how do we know there's 4?
The amount of line or no?
The base of it is a
Yeah, the
rectangle.
base. Yeah.
The base of it, because it's a rectangle, we can see that that has to be a plane, that has to be a plane, that has to be a plane, and that has to be a plane. So there's 4 planes plus the base, which is 5.
Mm-hmm.
Give another name for plane W.
I don't know. A, B, or...
Well, let's think of planes the same way we think of lines.
Mm-hmm.
I think that's the only answer I can even think of. So if we talk about the plane ADCB,
Mm-hmm.
that's the same plane as W.
Okay.
In the same way, if we go back up for a moment, you notice how another name for line B was HK?
Mm-hmm.
Even though HK has ending points, but that would be called HK line is the same as B. HK line segment is not the same as B. So it all
Mm-hmm.
depends on what you put over the top of it. This means a line. This means a segment, I think.
Mm-hmm.
I think that's the main thing. And so if you apply that logic to the plane in the ADCB perspective, then that plane is the same as W. Now, I don't know if, I'm not positive about that. The only reason I say that is because they act like there is an answer, give another name for plane W. And I would think the only thing it could be would be ADCB.
Mm-hmm.
Again, it's like the difference between a line and a line segment. In other words, ADCB would appear to me to be a plane that is closed on 4 sides. And
Mm-hmm.
W is not. W goes to infinity on all 4 sides, east, west, north, and south.
Mm-hmm.
So I'm a little not sure of the answer to 6.
Okay.
On and maybe their questions will reveal it. Give another name for, or name the intersection of ADE and plane W.
C or B, right?
What?
Would it be C or B?
No. First of all, here,
No.
let me shade in the plane they're talking about. That is AED or ADE. So where does that intersect the plane at the bottom?
Um,
It's a line.
AD?
Yeah.
Oh, okay.
Okay. AD. visible. Where does plane AEB intersect plane W? Excuse me. Yeah, no, ABE. Where does that intersect that plane?
DC?
Okay, here's the plane that I'm trying to refer to. This front one, right here.
Okay.
Where does that intersect the line? That's ABE.
Mm-hmm.
Where does that intersect the plane?
AB?
Yeah. In other words, just follow it down.
Right.
Wherever it intersects, that's the place that it intersects it, right there.
Mm-hmm.
And number 8, name a point non-collinear to points A and B.
And B. E.
Okay, that's good enough. How about another point? Oops, hold on.
Isn't that it?
No, there's actually a few others. How about C? I meant to circle.
And B.
Not call
Or
it.
and B.
C is not collinear to A and B. It's not on the same line. When they say collinear, it has to be a straight line.
Mm-hmm.
Okay, so if I have something like that, and I label it A is that point right there, B is that point right there, A and B are collinear, and B and C are collinear.
Mm-hmm.
But C is not collinear with A and B. It's not on the same line as A.
Mm-hmm.
All right. So, next page. Close that one out. Let me, first of all, before you do anything, let me look at my downloads here. Let me pull up the next. I think I've got 2 of them here. That's 35 and that's 33. So I'm guessing the next page is 33.
Mm-hmm.
Let me open that one and you tell me if this is where we want to go now. And let's rotate that 90 degrees left. Let's see what we're looking at.
Yeah, this is it.
Okay. All right, I see what's going on. Okay, find the value of the given segment. Find the distance. Now, most people look at that distance formula and they get freaked out. No way can I memorize that. It's too complicated. Well, guess what? It's just the hypotenuse of a right triangle.
Mm-hmm.
In other words, if I complete the right triangle, notice that the distance of that black line is the size of the hypotenuse.
Mm-hmm.
Well, this distance is the difference between the x-coordinates, which is what that is up there. The difference between the 2 x-coordinates. This distance is the difference between the y-coordinates.
Mm-hmm.
And that's the right way to write it. Delta x means the distance between the 2 coordinates. And guess what? I don't really care whether it's positive or negative. Why? Because I'm going to square it anyway.
Mm-hmm.
So you can actually reverse these x's. You could make it x sub 1 minus x sub 2 if you wanted to, and leave the y's the same. Okay, so good to remember. But in terms of this, it's if I start with c squared equals a squared plus b squared, what theorem is that?
What?
At the top, do you see c squared equals a squared plus b squared?
Mm-hmm.
What is that called?
Pythagorean?
Yeah, that's the Pythagorean theorem. It only applies to right triangles. Okay? Well, what does that make c? If c squared equals that, then c is equal to the square root of a squared plus b squared.
Mm-hmm.
Okay? Well, notice that that's a, and that is b. So that's how you get the distance formula. It's the same as the length of that hypotenuse, which is the square root of the difference in x's squared plus the difference in y's squared. So let's apply it to these 2 points. So how do I calculate the distance? Here. I'm not gonna rewrite it because you can see it right there.
Mm-hmm.
All right, what's x sub 2? Let's just fill in for x sub 2, x sub 1, y sub 2, y sub 1, and then we'll do the math. Don't try to do all of it at the same time.
Alright, so it'd be -2.
Hold on. My thing is screwed up here. Shoot. Let's try again. -2, okay.
+3.
Or it's actually minus a -3, so that's fine.
Doesn't that turn into a plus?
It does.
Yeah, okay.
When I say plug in, I generally mean just go ahead and plug in and don't do any math at all. In other words, I could have written that like this. I could have written it as -2 minus a -3. And that way, now you can simplify it. And now that becomes -2 plus 3. But the problem with doing it the way you did it is you're doing a step in your head. And I don't have any problem with that if you never make a mistake. But if you ever make mistakes, the best way to not make them is to don't do any math in your head. Just stick it in there and then simplify it. What's the rest of it?
So then it'd be
remember, you can do it in any order you want. So what's
so
the
10 minus 3?
Yeah, 10 minus 3. So that, I'll go ahead and write it. 10 minus 3. In other words, you don't have to do it in the same order as you did the x's. Unlike slope, when you're calculating slope, you do have to do the numerator and the denominator in the same order. But not with the distance formula, because you're squaring it. The only difference between doing it in the opposite order is it gives you a negative number or gives you an opposite sign. Okay. So this distance equals the square root of what?
So it'd be...
In other words, now simplify it.
1 plus 7.
7 squared. No, I didn't write it very clearly, but it's, remember, everything.
Oh yeah, 7 squared. So
yeah, everything inside the radical is squared.
49.
Okay. So that's over here on the right. I'm going to write that is the square root of 50. Is that the answer you want to put in? Not if you can simplify it.
Yeah, no.
Like you would never give an answer of 4/6. You would always simplify it to 2/3. Same thing with radical signs. If you can pull a whole number out, then you should simplify it. If you can't, I would not write that as square root of 5 times square root of 10. That's not a simplification. It's true, but it's not a simplification. In order to simplify a radical, you have to pull a whole number out. So think factor. Factor 50 into 2 things, making sure one of those things is a perfect square number. What factor of 50 is a perfect square number?
Um, 25 and 2.
Good. 25 goes there because I'm going to take that out as a whole number. Square root of 25 is 5. So there's your answer right there. 5 root. Put that into a calculator and it'll give you exactly the same number as root 50. But if you're looking at multiple choices, that's never going to be a multiple choice. You're always going to be looking at 5 root 2. In other words, the simplified version. Okay, midpoint is actually even easier, despite how complicated that formula looks. If I give you an x value of minus 6, and I give you another x value of plus 6, where's the midpoint between those two?
0?
How'd you get it?
Just math. I like.
Okay, no, you figured out that 0 is halfway between minus 6
0.
and plus 6, right?
Yeah.
Okay, now let's do this. Where's the midpoint between those two? Minus 4 and 8.
Would it be negative 4?
No, we're looking at midpoints.
Oh, okay. Would be 0 or
no? 0 is how far away from negative 4?
Negative 4 or 4?
4 units away. Okay. How far is it away from 8?
8.
Okay, so it can't be the midpoint. Midpoint is defined as it's equidistant between the 2 points. So here's how you do it. You add the 2 numbers together and divide by 2. So what do you get when you add minus 4 and 8?
Get negative or 4.
Divide by 2?
2.
That's the midpoint. Notice that 2 is 6 units away from minus 4, and it's 6 units away from 8. Okay? So, I don't want you to use that. I'm not sure why they put it up there like that. I'm really not. I'm confused. Because it's the sum of the 2x coordinates divided by 2. So what's the midpoint between h and k?
So it'd be negative 4.
Do the x coordinate first.
So it'd be negative 8.
No. Add the 2 numbers and divide by 2.
So it's negative 6. So it'll be
no, hold on. Add the 2 numbers. What's minus 1 plus minus 7?
Negative 8.
Divide by 2?
Negative 4.
Is negative 4 the same distance from minus 1 as it is from minus 7?
Yes.
Yeah, that's the midpoint. How about the midpoint between the y coordinates?
It would be 2 or negative 2 divided by 2, which is negative 1.
Is negative 1 the same distance from 2? How far is it away from 2?
Or 3.
Correct. How far is it away from minus 4?
3.
That makes it a midpoint. That's the easy way to do these. Frankly, I'm at a loss for this. Because that says subtract them. I don't get it. You do not want to subtract them. I think that's a typo. It should be x sub 2 plus x sub 1 divided by 2. And the y-coordinate is y sub 2 plus y sub 1 divided by 2. I've been doing it that way for 10 years, so I don't know where they're getting this formula. And that formula does not appear to work here. What if I took minus 7? They're saying take x sub 2, subtract x sub 1, and divide by 2. Well, that doesn't give you the midpoint. That gives you minus 3. That is not the midpoint between -1 and -7. So that's got to be a typo on your...
Oh, yeah. He said that's a typo.
Okay, good.
Yeah, I forgot to tell you.
It's all right. Okay, let me close this one out. And we're just about out of time. Let me open this real quick, and if you have any questions on it, I can do it. Okay, let's look at 18.
Okay.
PQS is 16 degrees. SQR is 9x plus 17 degrees. And PQR, this angle right there, is 12x minus 6. And I draw it separately just because it's difficult to label otherwise. Understand why I drew it outside of the original line. In other words, 12x plus 6 is this angle right here. I could do it like this. Here, let's do it like this. Or 12x minus 6. So, if we're going to try to find PQR, geometry is always about coming up with an equation that is true. What can I say about this picture?
What do you mean?
Well, I got one angle here. That's 16. Got another angle there. That's 9x plus 17. When I add those two angles together, what do I get?
16?
Get 12x minus 6.
Oh, yeah.
Right? In other words, the first small angle, that one, is 16. If I add it to the second small angle, which is 9x plus 17, I get the full angle, 12x minus 6. Once you've got an equation, now it's an algebra question, not a geometry anymore. And 12x plus 6 is what they're looking for, but we don't want to give the answer, or minus 6. We don't want to give the answer like that. We want to solve for x, and then we'll know what 12x minus 6 is. So how do I solve that algebra problem for x?
So you do, so for x, okay, so minus 9x.
Good. So that's going to give you 3x over there. What are you going to do with all the numbers? Put them on which side?
The left side, so you're going to plus 6.
Keep going.
So that's 17 plus, that's 39, right?
Okay, so now solve for x.
And then 39 divided by 3 is 13.
Okay, so x equals 13. So now what does that angle equal to?
It would be equal to 12.
Do you have a calculator?
Yeah, I'm getting it right now. So it would be 150.
Okay. That's how you do those. All of these kind of geometry problems, you try to find a relationship between the two angles or the three angles. And in this case, the two small angles add to the bigger angle. So I'm able to write, there's the two small angles, there's the bigger angle. I have one equation, only one variable. It means solve for that variable. Once I solve for x, I can figure out what 12x minus 6 is. Okay? Blake, I think you're on for tomorrow night also.
Yep. What time again?
Hold on a second. Let me look real quick. I think 7. I think all of the... No, sorry, 3:30.
Yeah, we had to cram it in there because I have a football game later that night.
Okay.
So.
I will talk to you at 3:30 tomorrow.
All right, cool. Thank you.